Hello there. My name's Brett. Nice to meet you. I'm an instructor here at SAIT, and it's nice to see you want to be a pipe fitter. So we're going to teach you what to do today. First period, pipe trades. You're going to be building a spool project. This is what it looks like here. So there's a variety of reasons why different piping systems are built. They're to carry process fluids, they're for energy purposes, for heating purposes. But part of your job in the pipe trades is to build it. Now, as a pipe fitter, we need to fit it together so a welder can weld it. Now, what are we trying to do? Well, the goal for this project is to put a flange, a piece of pipe, which we call a pup, and then an elbow. So we have those fittings. This is what it's going to look like when you're done. How do we get there? That's our goal. So you're going to receive your project sheet. On your project sheet, you're going to get some instruction. You're going to see where it falls into the course outline. Well, why are you learning this? Because in this trade, there's going to come a time where you may need to do some pipe fitting. So that's what we want to teach you. If you open up your project sheet here, you're going to see some information. You're going to see some references to your IPT Pipe Trades Handbook. Valuable handbook. Why is it called a handbook? So that you can hold on to it, take it with you. You don't have to remember all this information right off the bat, but it's a resource. You also get some instruction on the project. So you're going to see a number, 20 inches, F-C. Well, what on earth is that talking about? Face to center. So for measurements, what you're looking for is when you have a flange, well, the measurement, because this gets bolted up to something, whether it's a piece of equipment, whether it's a pump, it needs to get bolted up somewhere. So we need to take a measurement from the face of the flange to the center line of the pipe. So F to C, that's what it means, face to center. Then you're going to see another measurement, 8 inches, E to C. Well, we know what C is, that's center. What's E? E is end of pipe. So there's going to be a piece of pipe up here. So from the center line of this piece of pipe here to the end of the pipe, we want to see 8 inches. Now there is some things that we need to remember when it comes to working with steel pipe. We need to be safe, safety first, right? So what do we need to have when we're working on these things? Well, some of the tools of the trade. A pair of safety glasses. Those are always good. Put the safety glasses on. A welder's beanie. Well, why do we wear a welder's beanie? Why do they always kick it off to the side? It's because it keeps the little sparks from going into your ear. Okay, that's why we want to do that. You're going to have a welding helmet. Okay, a couple types of welding helmets. These are the manual type. Okay, they have a lens in it. So that lens can be usually about shade 10. It could be shade 11, could be 12, depends on the brightness of the arc. Then there's a clear shield. So I prefer using these types because you can use it as a combo where you can grind and you don't have to switch your helmets all the time. You can also get an automatic welding helmet, something like this. So it's an auto darkening. So you can put it down, you can see where you're at, then as soon as you strike your arc, it darkens to protect your eyes. Other tools of the trade that you're going to have is a pair of welder's gauntlet gloves. Very important. They got a long sleeve on them so that they can protect your wrists from sparks when you're grinding or welding. There's a variety of different types of gloves, so pick what's going to be comfortable for you and to fit the application that you're working with. Something else that is important for a fitter is what's called a wedge. Not sure if you can see that. So what happens when you work with heat, as you're going to learn in your apprenticeship, is that heat affects things. The hotter it gets, it will expand. Then when it cools, it shrinks. That's a reality that we understand takes place. So what this wedge does, it is a solid, immovable object that you put into your gap so that it holds your pipe where it needs to be during that heating and cooling process while it's moving. Okay? There is something that we all have to do. We always have to put a gap, what we refer to as a gap, into the piping. The reason why we do that is because this is what's referred to as a full penetration weld. Now, it's a full penetration weld because when you weld the entire wall thickness of this material, you actually get to take advantage of the entire strength of this piece of pipe that we're working with. So when it comes to pressure applications, generally you're going to have a gap so a welder can get in there, put his root pass in, which is the first pass, then he'll put a fill and a cap. And depending on wall thickness of the pipe, there's going to be a variety of thicknesses that he'll have to fill up. But our job is to give him something to weld. So what are we looking for? Well, we need to have a gap so we can a wedge so we can maintain that gap. The other crucial tool for us is a tape measure. We want to be able to read a tape measure. And then we're also going to want to have a square. Another piece of information that we're going to need to know is our welding electrode. That's what these are called. Okay, a welding electrode. Now the size, there's different sizes you can get. This is a 332 welding electrode. You can get 1/8 welding electrode, but I would recommend for your first time project as you're fitting, use a smaller rod. It's going to be easier for you to work with. Now, if you look at the electrode, you can see that there's some writing on it. Now this writing conveys some information. There's CSA E4918-1-H4. Okay, so this first number is for the CSA, Canadian Standards Association. E stands for electrode, 49 stands for the tensile strength. It is in megapascals divided by 10, so it's 4.9 megapascals. The next digit 1 is the position that the welding electrode can be used in. 1 in this case means it can be used in all positions. Number 8 refers to the flux coating. Now that flux coating, that information about 8 tells you what type of rod this is. It tells you what type of polarity you're going to put the machine in so that you can use this. Okay? And then 1 and the H4, that is the metallurgic properties of the rod. You can see the next is AWS. Well, that is the American Welding Society. Again, we have an E, which stands for electrode, 7018. So 70, that's tensile strength times 1,000. So as welded, that means that this rod can withstand 70,000 pounds per square inch of tensile strength or pulling strength. 1, we saw that before, that is the welding position of the rod. That means all position. 8 is the flux coating. So this is a lime coated rod. There's a reason why it has to go into a rod oven. That's to keep moisture out of it, because moisture can lead to what is called hydrogen-induced cracking. You want to be careful when you're handling this rod. Here at SAIT, whatever rods you use, you can put them back into the rod oven because this is what's referred to as a non-code welding shop. Because if you go in your careers, you might work in a fabrication shop where a lot of what the piping is in a building is prefabbed, it's called, in a fabrication shop, and then sent out to site. This is a non-code, which means that welding code doesn't have to apply here because you're just learning. So that means any codes that apply to this welding rod having to be in a rod oven don't apply, and you can stick them back into the rod oven because there is codes and regulations surrounding how long these can be outside of a rod oven and the temperature that they need to be stored at. So, word of advice, if you're ever working with a welder and he asks you to get some more 7018 welding rod for him, those packages are hermetically sealed. He's going to be a little upset with you if you go and open up all his packages for him because you're trying to think ahead. So don't do that. If he asks you to get him a few rods, just get him a few rods. Don't wear wet gloves because that moisture will get into the flux coating and again lead to hydrogen-induced cracking, and then the welder's not going to be very happy. So our electrode, an important tool that we're going to have. That gap, because we're a non-code welding shop, how does that mean that you can put welds onto a piece of pipe? What does that mean? Well, you don't have to be a welder to have your tacks cut out. Okay, so because it's non-code, the welder comes along, he doesn't weld over your tacks, he will cut those out. Well, then you don't have to be a certified welder to tack some piping together. But we need to know what we're going to do. Because when we put a pipe together, that's the welder's bread and butter. He makes a living based on what you do for him. So the more we can work with our welder, the better product we give to him, the happier he's going to be. And we're all going to be happy at the end of the day. There's not going to be any leaks, no problems. Everybody gets to go home, see their families, and enjoy some macaroni and cheese. Because let's face it, cost of living's going up. Who knows what else we can afford? So we want you guys to be employed. That's our mandate here. We want you to have the best training you can so that you're employable. Another tool that we have is our grinder. Okay, you have a backing plate that goes onto your grinder. You have a screw that goes onto your grinder. Now, if you look at this screw, you're going to be able to see that there's two sides of it. Now, one side has a little notch on it. That's for using thin little grinding or cutting discs. These we refer to as a zip cut. Okay, they're different thicknesses. This is 0.045 on an inch, so very thin. We use this for cutting into things. You can use it for adjusting your gap, but it's important that it goes on the correct way. So this writing that you see on it, well, that is going to get placed onto the grinder this way. You want to be able to look down and see that writing. Then we need to put this grinding disc in. And because it's so thin, if we put this little notch together, it doesn't matter how tight you try to make it, that still spins, nothing we can do. So you have to use the other side of the nut. Okay, the little indent, you see there's a little indent. You take that, spin it on, give it a little twist there, and now we're good to go. You can use one of these tools to tighten your nut, but quite often you're going to see out in the field that people don't. You put the little lock screw down here. There's a pin that locks the angle grinder, okay, and allows you to put some force and tighten, snug up, or undo. You do not need to put extreme force onto this nut to hold your particular wheel in. The other one that you're going to come across is a 1/4 inch grinding disc. Okay, so this is what we're going to use to grind any tacks down if we need to put a bevel onto the piping. Okay, this is what we're going to use. So we put it on. With the thicker materials, you're going to see you're going to want to put this little notch down now so that it keeps this grinding disc centered on the arbor. Okay, that's what we're going to do. There are other tools, other accessories that you can use. One of those accessories is a buffing wheel. Now, when it comes to welding, cleanliness is what we're looking for. We need to have it clean. With 7018 rod, you really want to get the flux coating off before you put any more weld on. You can use a handheld manual wire brush and a chipping hammer, or if you want to make it easy, use a wire disc on a grinder. So we talked about this backing plate. Okay, always keep that on. Whether you use a device that's called a cone stone or a wire wheel, if you take that off, what ends up happening is that this disc will go on too far, and then when it comes time to take it off, you end up breaking off this little pin because it's on too tight, and then your grinder has to go in for repair again. So again, you don't have to tighten it till there's no tomorrow, because it just needs a snug fit. Okay, so we'll take that. Well, some of you might be, but most of us, when we're doing this, working with the pipe fitting, is we are not certified welders. So again, we talked about non-code welding. The welder's going to come and cut your tack out, because we are going to do what's called a bridge tack. using a piece of rod like this, or you can take an electrode, and sometimes what you'll see is that a welder or a fitter, they're going to smack the rod and knock all that flux coating off. Now that the flux coating's been knocked off, you can use that as a bridge rod. So the reason why we do that is when we have a fit up to do, we put our bridge rod into that gap. So when I tack over it, I bridge both sides, the pipe and the fitting, or a pipe to pipe, whatever we're doing, and it keeps my welding away from this root. We really don't want to go anywhere near that because the root is very important to a welder. He needs to have a good root face, a good gap. He doesn't need any keyholes cut out of it because of our poor workmanship, because he has to have a good surface there to seal up that pipe properly with his root pass. So that's why we bridge tack. We want to stay as far away from that as we can. That's necessary so that he has a quality fit up to work with. Now, the other thing that we want to remember is that we are looking for a gap. Well, how big do you make the gap? And there's a few rules of thumb. So usually the rule of thumb is that we will match the gap to the land surface. If I'm using a 332 land, well, I'm going to put a 332 gap in. If I have a 1/8 land, I'm going to put a 1/8 gap in. However, again, there's rules, there's codes that apply to things. So that land, that root face that we're going to be working with, we don't want to go thicker than 1/8 of an inch. That's what we're going to be working with. Now we need to talk about putting on a bevel angle. We need to put a bevel on that. The reason why we need to put a bevel on that is so that when the welder's welding, he can get close enough to that root so that he can get proper penetration. He can tie that filler material into it and it gets full penetration, so we get full strength of that material. Now again, there are different angles out there. The IPT book says a lot of things. It says 37.5 plus or minus 2 degrees. But the code, the welding code that we're looking for is with carbon steel pipe. Okay, AWS, the American Welding Society, says that we're going to be working with a 30-degree bevel angle. So 30 degrees, that's what we need to have. Now, how do you get that? Well, you can always look at a brand new fitting. If you get a piece of pipe that's beveled ends, that's 30 degrees. If you need to take a torch beveler or a bevel machine, it's 30 degrees. That's what we're working with. And so you need to set your torch up at 60. The remainder out of 90 degrees is 30, so we end up with a 30-degree bevel. What happens is that if we have too steep of a bevel, well, as the welder is welding with his root pass using a 6010 weld electrode, which is a deep penetration welding rod, he can actually start burning away this. There's not enough material here, and it'll start melting away quicker than that electrode can fill it. That's a problem. So it can lead to keyholes that need to be repaired. It can lead to excessive penetration, which is a weld fault. So we don't want to go there. We want to make sure that we're working with a 30-degree bevel angle, and we can use a bevel gauge. You can take 2 nuts, put them together, and maybe we'll do that. Let's take a look at those 2 nuts. The 2-nut trick. So what you're going to do, if you want to make your homemade bevel gauge for carbon steel pipe, is put 2 nuts together like this. You can sit there, you got a welding machine handy, so maybe just put a tack on either side. That keeps your nuts where you want to store them, right? So we have it. You put a flat end on here, slide it up to the edge, and you can take a look at your bevel angle. Now the bevel angle should match this angle right here. If it does, you got 30 degrees, and everyone's going to be happy at the end of the day. Now, let's get this out of the way. I don't have a flange. Oh, I got fittings up here. When we're working with these materials, you might say, I got a welder who will weld anything. Doesn't matter what I give him, he welds it. Well, there's a difference between commercial pipe and industrial pipe. So you want to develop good habits if you enjoy pipe fitting, because if you don't have good habits with pipe fitting, you're not going to be a pipe fitter for very long, because you have to put out quality product when you're putting things together. So industrial piping, there is very stringent regulations and codes that need to be followed, need to be maintained because of high pressures and hazardous fluids that are passing through the piping system. So when we're working with these things, a flange, for example, this is called a weld neck flange. Now this flange, if you look on the outside, there's information for us. It tells us what code it falls under, the B16.5. So you can go to the ASME code, look up the B16.5, and it's going to tell you all the regulations about materials that govern the manufacture of this particular flange. It tells us it is a 2x150. Well, that means it's 2 inch in size, which is nominal, approximate inside diameter, by 150. Well, that's the pressure rating of the flange, 150 pounds. Then you see an STD. That means standard. Okay, standard wall thickness. That is the standard wall thickness. Now we get into a variety of different wall thicknesses, and there's some information that you're going to learn about pipe and materials when it comes to wall thicknesses. You have extra heavy, you got extra strong, you got extra heavy. You have different schedules, SCED 40, SCED 80, SCED 120, SCED 160. Now all those different material thicknesses, those translate into different pressure ratings that a system can handle. So with a standard 2-inch flange, it is going to be handling pretty low pressures in comparison to what is out there that you'll find on an industrial scale. So when it comes to fittings, when it comes to a flange, this is a raised face weld neck because this is the face of the flange. It has a raised face that does the sealing. This is very important. When you're working with the flange, you want to be very careful that you do not cause any damages to this surface, because this is the sealing surface. If you nick it, if you gouge it, if you get weld spatter on it, that can be a problem, and it can lead to early failure of a piping system or leaks, which are undesirable. So when you're working with it, be very careful. Okay? You have a fab bench. You're not going to slide it around on the floor. You're not going to be sliding around on the table. If you need to put it down to work on it, throw a piece of cardboard down. Something that is going to protect this surface. That's very important. When it comes to our materials, well, the welding code states that we need to clean the coating, whether it's rust, whether it's paint, a minimum or at least 1 inch back from the edge of that weld. When you think about it, a welder, he's got to clean the outside, but he can do that because it's accessible. When these are tacked together, he can't get on the inside to clean it up. So what ends up happening is that any of these materials that are in there, they can cause impurities within a weld. So those impurities can show up as porosity within a weld. And again, that's a weld fault. It's like an arrow bar. You sit there and you have a bunch of little holes in there. And if you have those weld faults within it, well then those have to be repaired. What do we do if we have a piece of pipe and we need to cut it? What do we do? Well, one of our tools of the trade that we have is a soapstone. Okay, this is a flat rectangular piece of soapstone. This is a soapstone holder, okay, and just keeps it nice and in your pocket, do lots of things. But when we're doing it for layout, having a nice sharp piece of soapstone really helps us to have an accurate line, because when you're working with welding, we're working with things and accuracy is important. Once it's welded together, there's not movement that we can get out of it. If it's crooked, it's going to be crooked and things don't fit. If it's too long, well, then it's got to get cut apart and fixed. If it's too short, again, you got to cut it apart and fix it. So we have to remember how things go together, we have to have some accuracy, and it comes from having sharp tools. So you're going to take your soapstone, if you have a file, a half-round file, half-round bastard file, you're going to sharpen up your soapstone there till you get a nice sharp edge on it, and that gives us something that we can work with to make an accurate line. So what we're going to do then is we're going to put our piece of pipe into something that can hold it, and we're going to make a mark now. This is called a wraparound. Okay, we use it in a manner. So we want to take a measurement. Let's say you're going to take your pipe. So from end, we're going to go at 340 millimeters, or 13 3/8 of an inch. You take that, you're going to put a mark on your piece of pipe. Now I got a starting point for my measurement. I'm going to take my wraparound, and what I'm going to do is, maybe I don't know if you can see this here. I'm going to take these two edges here, and I'm just going to wrap it around like this first off, and I'm going to line these two edges up. What that does is help me to get something nice and straight. Then what I'm going to do is I'm going to pinch the two sides, and I'm just going to wiggle it over, right over to my mark there. I'm going to hold it. Now I got a nice way of putting a straight line around a round pipe. I'm going to take my soapstone and I'm just going to trace around that edge. Because I have a nice sharp soapstone, I'm going to have a nice crisp line. Now I have a nice straight line. So again, when we're putting things together, when it talks about gap, when we talk about root face or land, when we're talking about bevel, consistency is the key. We want it all to be consistent. Okay, if we're not exactly 30 degrees, if we're 31 degrees, if we're 29.5 degrees, that's not the end of the world as long as it's all consistent. If you go from 30 degrees to 37 degrees to 25 degrees, that is very, very difficult for a welder to weld it, and they're probably going to say no, that has to be repaired. So it depends on application, of course. If it's non-critical, if it's a vent line, if there's no pressure, he might come along and weld it out for you. But if you think, my welder's going to weld that, just tell him that's the joint that he's going to get x-rayed, and then see how closely he takes a look at it. So consistency is important. That land, okay, that is important, consistency. If it's a 332 land that we're working with, keep it consistent all the way around. That gap is important. If we have a 332 gap, keep it consistent all the way around. Because what happens is, because of Ohm's law and the way things work with electricity, when there's more resistance to something, it changes things. It changes voltage, it changes amperage based on that relationship. So that's dependent on our bevel angle. If that's changing all the time, well, the welder, as he's going around, he might not get to fully penetrate into that because the thickness is too great, or it's too thin now, and so it's melting away quicker than he can do it. And it does not make things good for him, or it doesn't make his life easy. So we have to do our job so that he can do his, and everybody's happy at the end of the day. So now that we put our mark, we know where we're going to cut it. We want to have a square cut. That's why we use a wraparound to give us a nice square line. It's nice and crisp. And we're going to put our zip cut on so that we can make a cut. We're going to take our grinding wheel, our zip cut, going to make sure our backing plate's on there. And I'm just going to take it and snug it up. Now it's very important to stop your grinding disc before you release your tool. That's another safety aid, a safety tip for you, is just stop it so that it's not spinning. If it's spinning, you run the risk of it catching and spinning around, kicking around and hitting you, causing you some injury. So just stop it, it only takes a second. So now we've made a cut. Okay, gonna take your square and see how you've done. Square it a few places around, and the goal is to see that it's touching both sides evenly. If it's sitting like this and you can wobble it around, it's not square. We got to rectify that problem before we begin, before we start fitting. So now we've had some work on this. Okay, you can take your half round bastard file. Okay, we take that burr off. Now again, we talked about making the inside nice and clean. There's a coating on there. That coating can make its way into that molten metal as the welder's welding, so we got to clean it off. Now there's a variety of different tools. You can use a die grinder with a burr tip on it, and you sit there and you clean the inside of it. Let's see, where is one? Is there one over here? Die grinder with a burr on it. Now we can sit here and we can clean the inside of our pipe. Need to be careful. You could see that I wasn't sitting there grinding till the cows come home. Okay, I just took that coating off there. We want to have a nice clean surface so that we don't have any possibility on our end that there's going to be a weld fault. So now we sit here, we have our piece of pipe. We're going to just spin this a little bit, and we're going to put a bevel on it. Now the thing to remember when you're using a grinder to bevel is that it's practice, just like welding. Okay, it just takes practice for your arms to develop muscle memory, but the key is doing it at the proper angle to begin with. Take our file and just take that burr off. Now what you've done on one side, copy and repeat on the other side. We have an elbow. It's always good to check that your elbow's square. So, square is pretty square. So put it on there. See if there's any wobbling on it. If there is, it's not square, and we need to address that. So we put this on here, and our elbow's nice and square. We also need to make sure that our fittings are in the proper shape to be welded in. So again, they get painted or a coating on it, and there's different purposes for some of the coatings, but largely in this case, this is to prevent it from rusting out while it is in transport or sitting in the yard or wherever it is before it needs to get used. So again, we need to clean those coatings off because on the inside, very difficult once the pipe is tacked together. Our flange, well again, when you're working with a new flange, from the manufacturer, they should be pretty square. However, you always want to double check. It only takes a couple of minutes to double check things, and if you double check it, well then you know. So you just put your tape measure in there and you measure it. Check it all the way around, a couple different points, and you're able to see if you have the same number, it's square. If that number changes, it's not square. And you need to use your tools, your grinders, to face it off, make sure it's nice and square to the face of the flange. And then if you need to re-put a bevel on it. If we're working with our flange, we put it into a vise, great tool for us. However, you got to be careful that we don't mark our sealing surface, our face of that flange. Now there are some flat face flanges that we got to be very careful with, jack flanges, all sorts of different types of flanges that you may come across. In this case, if we use our vise just to grab the edge, that's great. We're not having to worry about damaging that sealing surface, and then it gives us something to work on as we need to touch up our bevel on the neck of that flange. What you saw me doing with the flange was touching it up, making sure that there is no weld around the outside. It's what's referred to as a reclaim. So we reclaim a fitting. Why do you need to do that? Well, there's some reasons. Something was put and instead of going right, I gotta go left. There's a distance, I gotta make it further, I gotta shorten it up. There's something happened. Now, well, why don't we just buy a new fitting? Because there's nothing wrong with this fitting. It's still good, it's brand new, it hasn't been used. So we want to reclaim it, and that's part of our job. That's something that you have to do. Sometimes errors are made, sometimes, and we just need to reclaim a fitting. So when we're reclaiming it, we're trying to take it back down to like new condition so that it can be reused, welded up, and there's no problems. So that reclaim, it is an important aspect of what we do. That's why it is a marking component of your project, is cutting your flange off, making sure that you're not gouging into the fitting, you're not digging into it, you're not cutting it off unsquare. We got to do our job. Okay, that's part of our job, and we need to make it clean so it's reusable. Important aspect of being a pipe fitter. Now that we're ready to begin our project, we want to get set up with our welding machine, our power source. So what we need to do is, first of all, turn it on. There's a switch on the side of it here. Just simply flip that up and you'll see it light up here. Now, there's a cover plate on it. These particular machines can do a variety of different welding processes. So the process that you're going to be doing is what's referred to as the SMA process, S-M-A-W. So that is shielded metal arc welding or stick welding. So there is a dial in here. We want to make sure that that dial is pointed to stick setting. There is another dial that we have that's referred to as arc control. So we're not going to get into the sciences of how this all works, but just keep that arc control machine or setting somewhere between 40 to 50, and that's going to work out fine for you. We have another knob up here. It's V/A adjust. So that stands for voltage or amperage adjusting. Now this adjusting, it depends on the process that we're using. In this case, it's going to be adjusting our amperage. Now the amperage is something that is the heat setting of our welding power source. That current passing through, it enables us to fuse these metals together and therefore we're welding. So what do we set it to? We can turn it all the way down to 0, or you can go way up to 425 amps. So how do you know what to do? Well, with 7018 welding rod, there's a rule of thumb that can help us out get the setting if we forget. You can take your rod diameter. In this case, it's 332 rod. 3 divided by 32 equals 0.09375. Well, what does that mean? Well, I cannot set this down below 0. However, I can set it to 94 amps. So that gives us kind of the ballpark that we can run in for our weld electrode. So 0.9375, that gives us the range. For myself personally, I like to be a little bit hotter, so I like to run 96, 97 amps, but that's just my preference. Now, if you go below 90 amps, what happens is it can be a little bit too cool for the electrode, and you run into a little bit of problems with it sticking. It's not fusing properly into the material, so you don't want to go too low. If you go too hot, above 100 amps, well, again, it presents problems. It can burn too quick, you can burn through the material, you start burning your flux coating, and it wasn't intended to do that. So just take the rod diameter, that gets you in the ballpark. For example, a 1/8 rod, well, 1 divided by 8 is 0.125 or 125 amps. Gets you in the ballpark. So when it comes to this rod, well, how do we know? There's a couple of plug-ins here. Okay, one connection goes to what we refer to as the electrode holder or the stinger, the money maker. They're connected to these connectors here that simply are twist lock connectors in this case. So how do you know? On your machine, you're going to see that there is a plus for positive or there's a minus for negative. So this particular electrode, we're going to want to run in the reverse polarity setting on the machine. So to achieve that, we want to have the electrode in the positive connection. So just verify, you can trace your cables back. We have our electrode holder here, our stinger, our money maker. And so we want to trace it and see, okay, well, I got the right connection here. I'm going to plug that into my positive connection. With electricity, if we do not have tight connections or snug connections, we're going to run into problems. So just want to make sure you got a nice snug connection. You don't need to overdo it. No wrenches on it, just a nice little twist. Then our lead, our work lead, our ground clamp, we're going to connect up to our negative connection. And this setup is going to give us reverse polarity. Now there's a variety of reasons why we do this, but we will not get into that at this moment in time. Now again, we mentioned electricity. Where are we going to connect our ground lead, our work clamp? Okay, we need to, electricity always needs to complete a circuit, complete a path. So even though the machine's turned on, if my work lead is not connected, and I have a ground clamp in here, I can touch it, nothing happens, right? There's nowhere for that electricity to move. So we have to connect up our work lead. Some might have the tendency to, well, it's right here. I'll put it right on the flange. Or I got an open-ended piece of pipe. I'll just stick it in there. That is an undesirable and a bad habit to get into. The reason being is that if this wiggles around on our material that we're working with, it can create arc marks on there. Those arc marks lead to a very serious problem called a metallurgic notch effect, which can lead to a failure. So if we have nowhere to connect up our ground lead, well, he said don't put it into the pipe. What are you going to do? Well, we have tools like this. It's a chain grip. We can wrap the chain grip around there, have a nice snug connection on our chain grip on our piece of pipe, and then just simply put your ground clamp onto your chain grips. It will give you a connection, and then if you end up wiggling it around there, there's no damage to our piping system. The other things you can use is you can use vice grips, you can use C-clamps, but do not get into the habit of connecting your work lead directly up to the piping. So now we've got our machine hooked up. We want to have a good, clean connection. On this particular table, we have some bolts down here, so it's not painted. It's going to give us a good connection for our electricity. It's a good idea to connect it up to a bolt. So we have our work lead connected here. We have our machines turned on. Now, when I put a weld electrode into my stinger, it's live. You have to be very careful. Wherever we move this around now, if I touch it to something, I can start up an arc and we can flash. You can get a welder's flash. A sunburn on the eyeballs is what that is. It's painful. We can damage things. So just be mindful once you get this connected that it is live now. If I touch it anywhere, I will complete a circuit and welding will take place. So how do you fit it up? Well, there's more than one way to unpack a bar of soap. So there's a variety of different ways that you can do it. The way that I like to do it, in this particular case, I'm going to grab my flange pins. Now these flange pins are a tool that helps us to level out a flange. The term is referred to as two-holing. Now there's a couple of ways you can put a flange pin in. You can put it in this way. I would recommend against that because sometimes we have to put another fitting up, fitting to fitting here. And the problem with doing that is now that you've tacked it together, sometimes you can't pull your flange pin out and then you have to cut your joint apart in order to get your flange pins out. So it's always a good habit to put the screw end in this way. We put our pins together. We snug it up. And what we're going to do is that's going to give us a platform that we can put our level on to make sure that we're working with something level. So we put our flange pins in nice and tight. We grab our trusty level and we put it across here. Now we simply just get that bubble between the lines. Now we've got something that's good and snug. It's in our vise. We've made sure not to put our raised face or the sealing surface into our vise. Now I can pull my pins out. I got my flange secured. Now when it comes to fitting these types of things together, I prefer to start from the flange because that's my mating surface. If I square everything to my flange, then down the road, it makes things a little bit easier. When you're fitting pipe together, the more we handle this material, the slower we become in fitting a joint together. So if we put it together and I put a tack here and then I take it out and I flip it over and put another tack, well, you're making things harder for yourself. So once you get it set, I know I don't have to worry about this anymore. The next piece of material that I want to put on is my piece of pipe. So that piece of pipe is going to get butted up against here because it is a butt joint. So what are we going to do? How are we going to do that? We need to keep a gap in there. That gap again leads to penetration. So we can use a piece of welding rod here. You bend it in a V, and what that can do for us is that acts as a gap rod. That makes things even around for us. However, we only have a couple of hands. So if I'm trying to bridge tack and I'm trying to hold things and I'm trying to level things, it becomes very difficult. So we can always clamp a piece of angle iron onto our pipe, have that sit in there, okay, because there is something that's called high-low, and it is the alignment. When we're fitting material, what we're concerned the most about is the alignment of the inside diameter of our piping. Okay, so that's what we're referring to. We have to keep that alignment. There is a little bit of variance according to the welding code. We're allowed a 1/16 of an inch variance, but if you can get that down to nothing, that is obviously preferred. If we have a bit of high-low around there and it's a 1/16 of an inch, what you're going to try to do is try to even it all the way around so that it's less than that. A welder can work with that. So in my particular case, because I've had to fit materials up by myself, I've had to learn a couple tricks along the way. In working with 2-inch, in my particular experience, I've always found it's been a tricky piping system to work with, just because the fittings are small, they don't stay where you want them, and they slide around and move around a lot. So if you have a little bit of struggle trying to get it lined up, don't feel too bad. It takes a bit of experience and time in order to get it worked out quickly and efficiently. So what I'm going to do, I got my machine set up, got to put my welding helmet on. And I get my electrode holder, my stinger, the money maker. And I'm going to get ready to go with my welding. Now, what I like to do is, if I'm fitting by myself, is I will hold it butted right up against the pipe, because then with my thumb and forefinger, I am able to feel the outside diameter of the piping, and I can feel whether or not I am sitting too low or too high, if I'm even, and then I can just look down the edges and make sure I'm good on both sides. So with it butted straight up, I'm just going to put a tack in place to hold it here. Whenever you tack something in place, you need to hold on to it until that material stops glowing red. If you let go of it too quickly, that fraction of a second, it will shift on you sometimes, and then you're misaligned and you gotta take the grinder out, cut it apart in order to sort that out. So just hold on to it for an extra second until it stops glowing, and then it's held in place. So now what I'm gonna do is I'm gonna take my gap rod. So my gap, I'm going to want to have that set to 332. So this is what I have. I'm going to just change this direction, give me a little easier access. And what I'm going to do here is I'm just going to put the very edge, the very tip of this into that gap. And so now what I've done, if you stick it in too far, what happens is once it's tacked and it cools down, it tends to shrink and it pinches that gap rod in there pretty tight, and it's very difficult to get out. So if you just put it in just enough to hold it open, well then that is more than enough to keep everybody happy. So what we're going to do then is we have our bridge rod, and I'm going to put it into my gap because I want to cover over that. When you're using 7018 electrodes, with these electrodes there's an iron coating that is right on the tip of it, and that aids in starting the arc. Once you've burned that off, sometimes you can have a bit of a candy coating on the end of it, no bare metal, and it doesn't allow you to strike up an arc very easily. So if you can, just take your gloves and your fingers and chip that off. If you can't get it off, give it a couple taps on the ground so that you can just get to bare metal, and it's going to make starting up your arc a lot easier. So now that I'm here, I'm going to put it into place. And what I want to do is that I don't want to spend any time on my bridge rod. If I put too much time on this, it's just going to melt and fall out on me, and then you're going to run into a problem. So you can count in your mind on the flange side, just 1, 2, immediately over to the pipe side, 1, 2, and then you pull your electrode away and you're done. Okay, so that's what we're going to do right now. Now we've tacked the one side. Now what I need to do is I'm going to take my grinder, and because I've butted this up, I haven't come close to my root. So what I'm going to do is I'm just going to gingerly cut into that weld tack that I've put in place. I don't want to cut all the way into it, but I'll just take some material out just enough so that I can break that tack off. Now that I've broken my tack off, I need to use my wedge. Okay, so I'm going to put my wedge into place and I'm going to wedge this out. When you're doing your tacking, it's very important that we always tack directly opposite. Okay, if I put a tack here and then I put a tack here, when it comes to squaring up our pipe, it makes it very difficult for us. So we're going to grab our square. I'm going to come across the face of my flange, flat on there, and then I just measure. So if you can come over here, take a look at where I'm doing. If you pick a whole number, it's generally easier. You can slide this around, so let's go with 80. So if I go 80 here, I want to see 80 on the other side. And I have 80 over there. So that means that I am square from side to side. So that's good. I'm going to take my bridge rod now. I'm ready to tack this side over here. Okay, so now I've got a tack, two tacks opposite one another. That's good. Now, because I've squared it and I've left my wedge in place, I don't have to worry about it moving on this plane. Now I just got to worry about it being squared on the opposite plane. So when you have your wedge in place, I generally leave it there, because sometimes you fluke out and it's square the other way as well. So you just can put a tack in. So what we've done is, if you take a little bit of practice, I know this is squared, it's 2-holed, and I don't have to worry about it moving on me. If I go and I take this out of my vise now, and well, it's difficult to do that overhead tack. Yeah, they're difficult, but if we practice at it, it gets easier, and then we don't have to move this around, because every time I move it, then I gotta 2-hole it and I gotta square it up. So we're just gonna do the same thing here. So we're gonna measure down. I got 80 mils, and now I got 84 mils. So it's not square. So that's where our wedge comes into place. You can take your wedge and you can take a hammer and you can pound that up to move it. But what I like to do is just the little cold chisel. I've turned it into a little pry bar here for me, and it just makes it easier. I don't like using hammers onto these things if you can avoid it. So then you just use mechanical advantage and you get your wedge into place. Once you've moved it, you're going to take your tape measure and your square out again, and you're going to check your numbers. So if I go to 80, I got to pull it out just a little bit. Gone a little bit too far. $80 and 80. Because we're using a wedge, we have a square, we have a tape measure, we can get it squared up so that both numbers read the same. One thing that you want to keep in mind when you're working with material and you're fitting things up, and there's always shrinkage that has to be accounted for. So when we put something together, this material, there's kind of a rule of thumb that is going to be shrinking about 1.5 millimeters per joint. So that means this joint is going to shrink 1.5 millimeters. When this elbow is on here, it's going to shrink 1.5 millimeters. So total, with these two joints, it shrinks 3 millimeters overall. That means my face to center measurement needs to be 3 millimeters longer, so that after it's welded, it shrinks to the correct dimension. We have to remember those things. Different materials, thicker materials will shrink more than others. So that is something that comes with time and experience. But for most of this material here that you may be working with, 1.5 millimeters. So we're going to come down, we're going to do the bottom, do our overhead tack, then we'll go up and do the top of it. reason why I bend it up 90 degrees once it's still hot is because then it helps to fatigue the bridge rod a bit better and breaks it off right at my tack, and it just keeps things a little bit neater and tidier. Okay, we've got 4 tacks. Now the reason why we tack this is because I've squared this all together, and so a welder, he's going to come along and he's going to cut the tack out. So these tacks keep everything in place in transit while it's sitting on the floor waiting to be welded. Okay, he's going to come along and cut it, the remaining tacks, hold it where it needs to be so that it keeps itself square. The next thing we want to do is put on a 90-degree elbow. So, well, we're going to do the same thing. Again, I like to fit things in the horizontal plane because there's less handling of the material. We want to keep this material running all in the same line. So if I put it on this way, yeah, that works, but I can have this leveled, but I can actually have the elbow cocked off to one side or the other a little bit. When I fit it on the horizontal plane, well, when I do the top and bottom tack, I can put my level across this point and this point, and that will help me to match the line of my piping, so it keeps everything in a nice line here. So that's what we're going to do now. We're going to put this elbow on. So we're going to take our level, okay, because this is 2-holed. I want this to be square to the 2-hole here. I'm going to take my level. I'm going to get my electrode ready. And I'm going to do the same thing. I'm just going to butt it up. I'm going to hold it between my thumb and my forefinger. That way I can feel the high-low and I can look down the edges to see where I'm at. I'm going to take this because once it's glued together, it's very difficult to change that. Okay, so I'm going to get that level. I'm going to check my high-low on both sides. I'm good. I'm going to put a little tack here. Okay. So now we're going to bring out our gap rod again. We're going to open this side up and insert our gap rod just a little bit. We're going to want to check that face again. Make sure that we're level, or we're plumb. Vertical is always called plumb. Okay, now we're good to go. So I'm going to take it, grab my rod. I'm just going to spin this, give myself a little easier access. Get that flux off of there so it's a little bit easier to start my electrode. Now, when it comes to fitting materials, we have to remember that there is always forces that act on these. When you weld a flange up, well, it's all the same all the way around, so you can fit it up square. When you put an elbow on, because you could think it kind of piles up in the throat of the elbow, a 90-degree elbow is always going to pull more in the direction of the throat. So a good fitter, when they fit something together, it's always generally going to be longer and it's going to be out of square. Once it's welded, all those forces that act together, they shrink, they pull on things, and then it makes things square and the correct dimension. So there's always a little bit. So what we need to do is, when we fit it up, because it's going to pull this way because of that throat, you're going to want to have this face not exactly square to this, just a little bit open so that once it pulls in, once it cools down after it's been welded, it's going to be nice and square. And now we're going to take our trusty wedge, and we're going to put it in there because that is going to keep our material from shrinking up on us and causing us to be more out of square than we want to be. So we put our face across both edges here, and we're going to see what we are. So we have 45 mils there, and we got 45 mils there. So we're going to take it, open it up a little bit so that once it pulls itself after it's been welded, it's going to be nice and square for us. Going to check our square here. We want it to match. We know our flange is good. We're working off of our flange. Our gap is good, our set. So now we're going to tack the opposing side of what we've just done. Okay, so opposing sides, that's done. We're square and we're level to our flange. Now when I go across these 2 points, I'm going to check this pipe here, see where I'm at. I'm slightly over this line. So what I'm going to do is I'm going to make that the same. We're slightly over the line. That makes sure everything's running nice and square and nice and true to each other. And we have a good finished product when we're done. All right, we can pull our wedge out. We have our gap. We have our bevel. Everything's nice and even. We're squared up. We've taken our shrinkage into account. Now we can take it out, send it off to the welder. He can weld it. He can be happy. We've done a good job fitting it up. We can be happy. And I'd love to have you tune in again.